So now we're going to finish this section off with an application. So there's something that's called the CMYK color model, or the CMYK model, in which colors are encoded as four-dimensional vectors. And the way they're done so is that the four coordinates just correspond to intensity levels of the four fundamental colors: cyan, magenta, yellow, and black. So in the following table, you can see a bunch of colors that are listed. This is not an exhaustive list of colors by any means. This is just a handful, just enough to give you an idea. There's a table that involves some colors. Here are the actual colors if you want to look at a sample of the colors. And then the second column has their corresponding name. But then the columns 3, 4, 5, and 6 actually contain the intensity levels of cyan, magenta, yellow, and black for each of those colors. So you can use the entries in the third, fourth, fifth, and sixth column to figure out how to encode these colors as four-dimensional vectors. Let's take a closer look at the first one, apple green. Okay, so you can see that its cyan component, oops, pushing too many buttons here. Its cyan component is 0.3373. So you should interpret that as an intensity level of about 34%. That's how strong the cyan presence is in apple green. And then magenta is at 0, right? If you take a look at magenta, there's a 0 for the magenta component of apple green. So it's got an intensity level of 0. There's absolutely no presence of magenta in that color, apple green. Yellow is at about 65% and black is at 20%. Notice that these don't interpret them as proportions. They're just intensity levels of an individual color. These four coordinates are completely independent. If I have a high cyan percentage or value, if I had a value of cyan that was like say 0.95, there's nothing stopping me from having magenta, yellow, and black be very large as well. They don't add up to anything specific. They're completely independent. Okay, so let's look, how would you actually write apple green as a vector then? Well, that's one of the examples that's done down here. So just take those four numbers and interpret them as coordinates. And then you can define apple green as a four-dimensional vector. So, and I've used the symbol AG just to give it a label, just to quickly refer to it as a vector, but using actual notation for it. Notice I used two letters there. That's the first time we've done that. And you can certainly do that. There's nothing stopping you from using more than one letter, or you can even use a word to talk about a specific mathematical object, just like you can in a programming language like Java or Python or C, right? There's nothing stopping you from using more than just one letter. In fact, sometimes it's advantageous to do so when you want to add more clarity. Okay, so, and then red, blue, and yellow are the other three colors that are encoded as vectors here. And if you go up and if you look at the corresponding color in the table, so here's red here. Look at the values: 0, 0.8235, 0.7922, and 0.0745. Those are precisely the entries in the red when it's encoded as a four-dimensional vector. And yeah, that's it. By the way, one last comment before we move on. I've just, like, the first entry is just 0, right? I've written it as 0.0000 just to keep the number of significant figures consistent. It just makes it a little bit easier to read, but that's just to be interpreted as a 0. Okay, one more comment and then we'll move on. Let's look at a specific color like cyan, for example. That happens to itself be one of the fundamental colors in this coloring system. So what happens when you have one of those colors? Well, then look at its cyan component. It's equal to 1. So you should interpret that as cyan has an intensity level of 100% when it's in the makeup of the color cyan, which makes sense, right? Because it literally is the color cyan. So you're going to want to have that color turned up to the max. And then magenta, black, and yellow, well, they all have zeros because they don't participate at all in the CMYK makeup of the color cyan. It's purely cyan. And then you have the similar situation for yellow, magenta, and black. Like, black is made up of all black and has absolutely no presence of cyan, magenta, or yellow. Where are the other ones? Yellow is you can see it's 0 for cyan, 0 for magenta, and 0 for black, and 1 for yellow. And then which one did I skip here? Magenta, right? Magenta's got a 1 for the magenta coordinate and 0 for the other three. Okay, so let's take a look at this next example now, because what good are these codes? What's the purpose of this? Like, why wouldn't you want to just look at the color? Why would you be interested in these four-dimensional vectors? Well, let's take a look at this example. What are some of the what's a natural thing you can do with colors? You can mix them together. Well, what's going to happen when you mix them together? That's a difficult question to answer without actually just getting your hands messy and just trying to do it, right? But if you have the color codes, if you have the CMYK codes for colors and you want to mix them together, you can predict the result using linear combinations. So let's look at this example. So Bob is thoroughly mixing together some paints. So it looks like he's mixing together 1 gallon of red paint and 1 gallon of yellow paint. Okay, the important part here is he's just mixing together the same amount of each paint. So it's 50% red and 50% yellow. He's throwing that into a mixture and mixing it up and seeing what the resulting color is. And in particular, what we're asked for is what will be the CMYK color code of the resulting mixture. Okay, well, we can do that just by setting up a linear combination. So like we already mentioned, there's 1 gallon of red paint and 1 gallon of yellow paint. The important part here is not so much how much of each paint there is, but that there's the same amount of yellow and red being mixed together. So what that means is in the final mixture, red is going to account, the red paint is going to be 50% of the mixture and the yellow paint is going to be 50% of the mixture as well. So as a fraction, 50% can be represented as a half. So what we're going to build a linear combination. It's going to be half red and half yellow. And we're just going to add those vectors together. Just do the scalar multiplication and then add them together. So what's a half red? Half red, well, I'll copy these out. Red is the following: 0.0000, 0.8235, 0.7922, and then 0.0745. That's the red color as a vector. And then we've got a half times yellow. And yellow is, I got it easy on me here. I don't need to worry about all the decimals. I can just write 0, 0, 1, and 0. And then, how do you work these out? Well, perform the scalar multiplication, right? Take this 1/2 and multiply it onto each of the 4 coordinates of the red vector, and then take the 1/2 and multiply it by each of the 4 coordinates of this vector. And then add the 2 resulting vectors together, and then whatever you get, that's going to be the CMYK color code of the result. Now, because this is an application, I'm not going to worry too much about the details of all the calculations. You're going to use a calculator in the real world, right? When you're doing stuff like this. So I'm just going to jump right to the answer. But I got this with a calculator. I've worked it out in advance. So the color, and I'll write it out with all 4 significant figures here. So the first, the cyan component of the result is going to be 0, which makes sense, right? Because we're mixing together red, which has no cyan component at all, and yellow, which also has no cyan component as well. Well, it does have they do have cyan components. Those components just happen to be 0. It has no presence of cyan. So it makes sense that the cyan component of the resulting mixture would be 0 as well. Then the magenta mixture is going to be, it works out to 0.4118. And these are rounded off to the nearest 4th decimal place, which is pretty precise. The yellow component is 0.8619, and then finally the black component is 0.0373. And you can check that these values are correct. Okay, so that is, if you interpret that as a CMYK color code, that will tell you what the result is. Now, by the way, what would you expect to get if you asked someone that wasn't even taking this course and didn't know anything about linear algebra, and you said, hey, I'm mixing red paint and yellow paint together, what is the mixture going to look like? They'd probably suggest that it's going to look like orange, right? And take a look at the color code for orange. It's highlighted here. So look at the entries for orange as a CMYK color code, right? So the cyan component is 0. The magenta component is about 38%. That's not so far off of what we got here. We got about 41%. The yellow component is 98%, so that's a very strong presence of yellow. we got a fairly high yellow presence as well. It was 0.86, or about 86%, right? And then for orange, there's a very small black presence. Well, we got a very small black presence here as well.